patient. I'm a doctor, not a bricklayer.
How's it guys? Travis from Ostrich Lovnik here. In this set of videos which I'm making, I'm going to show you how to assemble the circuit for the USS Enterpris refit. I'm going to show you first the board on the how would I put it, testing phase, I guess you could call it. Can't think of the word now. Then I'm going to show you how to put it on this board. I've already got the housing for the chip, so I can do all the assembly without actually having to put the chip in place yet. So this is where I'm going to put everything. But before I show you how to put the stuff onto here, this is basically going to be a fake Arduino without all the unnecessary parts which you don't need once it's in your model. So you can keep your original Arduino, just remove the chip, put it on here, take a chip out of the package and put it in, and program the next one for whatever project you want to do next, and only have to buy one Arduino instead of having to buy a new Arduino for every model. So I'm going to show you how to make your own Arduino. There are some other websites where you can go and see the same thing, but the difference will be once I've done with this, I can explain where all the pins are for the photon torpedo effect and all the other stuff. So I'll be back now. Okay guys, I'm back. One important thing which you get, sorry about that. One important thing which you need to do is to go get the pin layouts from the Arduino website. If I remember, I'll try to put it in the description. Basically, that's it over there. Sorry about the tripod shadow. It shows you each pin, which pin is what are, I don't know if I, for argument's sake, pin 13 on the Arduino is pin 19 on the chip. So this will show you exactly where to put each wire once the circuit is being built. So getting this piece of paper will help you a lot with where the voltages are, the grounds and all that stuff, and it will help you sort out what to do with what. Now I've just got to still connect this up to power, but sorry, there we go. That is the basic layout of how the board's going to finally look. I've got a crystal, I've got an LED, and I've got two capacitors, and that's basically the whole bare minimum Arduino which you need for this circuit to work. Over here I've got my power source going from 9 volts to 5 volts, and my LEDs and all the stuff already there for the circuit to work. So just give me a second and I'll quickly connect the power supply up to it, and then I'll show you how it works. Be back now. Okay guys, I've got the power connected up. Now it's just a matter of switching it on. And there we go. The deflector dish ramps up. Nav and strobe lights are going. You can see my little green light over here, which will be a part of the board just to show that it's working. Over here I've got my different buttons: deflector dish, photon torpedoes and phasers. At the moment the phasers set to the Defiant class starship's rate of fire. This one of course it will be white, not blue, that will also be white, not blue. There will be, I think it's this one, no, that one will have a red and a green as well. The deflector dish is by LEDs, so it can go orange or amber, and it will go blue. Then of course I've got for my phases, and I've got two for my, now you can go watch this video. This one was made by Trevor, where he shows you the programming and all that stuff. And then I press this button, the deflector dish changes. Press it again and the deflector dish changes again. Now when you press the deflector dish, you can't fire the photon torpedoes or the phasers. So here goes photon torpedoes. And phasers. Now that when I get a chance, I'm going to change that effect to one long burst. Trevor does show me how to do it on another video which is done, which I still have to do. Then I'll program the chip that's still on this Arduino here. I'll program this chip with a new phaser, and then I'll make that a permanent part of this. So you now see how it all works. Now I'm going to build it, and then you can see exactly what I'm doing and see just how simple it is. And once this is made from here, once you've got it programmed and you've got your board built, it's just a matter of connecting all the wires up, putting the chip in, and it's done. So I'll be back in a minute, and then we'll start with the soldering and getting all the stuff together. Be back now. Okay guys, step one, I am going to be using a crystal. Actually that gives me better light with that on. This is what they call a crystal. This one is, let's see, what I'm using, I think it's a 16,000. I'm not sure if it hurts, but this was got 16,000 written on it. Now, the nice thing about this page is it tells you crystal, actually it's got written here crystal, which is pin 9 and 10. So starting from the notch over there, which always means if you're looking at it this way like that, and the notch is in front of you there, to the left is always pin 1, to the right is always the last pin. This has 28 pins, so pin 1 will be on your left and pin 28 will always be on your right as you look at it. So according to your sketch, it says crystal must go between pin 9 and 10. So on your board you would have to take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm just going to use the pin to mark it. So I now know where my pin 9 is. I think it's pin 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so there's pin 9. And I can take my crystal and I can put it in there. So now I want to try to save as much space as I can, so I'm going to put the crystal in and push it down. Now I've got my crystal in place between pins 10 and 9. I can now bend my wires on the other side to help keep it in place. Now the other nice thing to have is a helping hand. So I can take my board and I can clip it in to the helping hand, and that will keep my board nice and steady. So now all I need to do is grab my solder. I've got my big reel over here with all my soldering, but this thing's pretty heavy to hold when it's still full. So what I like to do is just take a piece of plastic, wind a little bit of my solder off like this, and it's much lighter to hold, especially when you're doing a lot of soldering. So you don't have to hold that heavy piece of material. Considering how much solder it's got on, it's pretty damn heavy. Bend my pins so I can try to keep them steady, and put some solder down, just heat the solder up, and there we go. Now apply solder to other side. Okay, and there we go. I can loosen it, and my crystal is in place, as you can see there. So that is step one of creating the board. I've just got to quickly find my little capacitors, so I'll be back in a second and I'll show you where to put them. Back in a second. Okay guys, next you need 2 microfarad, 20 microfarad capacitors, these little ones. It's got a 20, a 22 will also work. Now this must go between ground, which is pin 8, and pin 9, and the next one must go between ground and pin 10. The reasoning for this apparently is it helps smoothen it out, so there's no fluctuations or anything at all. I'm not exactly 100% understanding of this. Got a basic understanding of these things. So let's see, that's got to go between pin 7 and pin if this thing will cooperate. There we go. Is that right? Yeah, that looks right. 1, 2, 3, 4, 5, 6, 7. Sorry, I mean pin 8. 1, 2, 3, 4, 5, 6, 7, 8. Pin 8 and 10 is the first ones. So just get my helping hands in place. Okay, I've got it in place. Now what I've done is I've used the one leg just to bend it over to keep it in place, so I can put some solder on the other leg. There we go. Heat that solder up and push the little press it in place. Always remember, electronic parts do get pretty hot when you solder them, so be prepared for 1 or 2 little burns. And now I can solder my other leg into place. Okay, so that is one down. and 1 to go. So between pin 10 and ground, I put my next one. And secure it in place, just grab it with my helping hand. Just check, okay, there, we have a bit of a solder. Once again, just drop some solder on the first one. There we go. Put my soldering iron away. Loosen the clamps. Okay, so there we go. That is the next step. And always remember, there is normally a little pin sticking out at the bottom, which you don't need, so trim the excess pins off to keep yours nice and smooth. Because you don't want those pins coming into contact with anything metallic. So the shorter you can keep them, the better. Okay, so that's how far we are so far. You've got your 2 capacitors and your crystal in place. Next, I will need an LED with a resistor for the next part, so I'll be back in a second. Be back now. Okay guys, next I'm taking a 3mm white LED. Now I like to recycle LEDs. I find them on old keyboards, mouses, all sorts of different things, little strips of LED tape. Sometimes when you strip these off, they might be short, the pins might be very short, but they work perfectly for doing little projects. You don't have to clip them, so it's quite easy. It's nice to use these. Now if I can just find what I'm looking for. There we go. Now a lot of people say, but then how do you know which is the positive and which is the negative leg? Just a simple little watch battery. You put it on and you'll see where there's negative and positive. If it comes on, you know the leg that's touching the part negative, that's the one you're going to use for negative. So there's the negative one. So I now decide, okay, I'm going to use this area over here. I'm going to put it in like that. For my LED, I'm going to put it there on the side. Turn it over. Okay, I need to go one more line over, otherwise it's too far over. Okay, that's perfect. Once again, grab it with my helping hand. And I'll just need to bend the pins a little bit over. Okay, there they stay. That's perfect. Now there's just enough pins for me to solder, so back, and there we go. So that is that step there. My LED is in place. Not quite happy. Oops. That's better. Okay, so now I've got my LED in place. Next, I'm going to need, as far as I can remember, this is a 10 ohm resistor. The colors are brown, black, orange, gold. So I come in, I look here, I've already pre-bent this one, but my resistor needs to go through from digital pin 13, because on a Arduino the little LED located in this area, and pin 13 is connected, but it's also connected with an onboard resistor. So when you build your own Arduino, you have to put in a resistor. So now, just to make sure I have got my LED the right way around, I'll rotate my battery according to where ground should be, and I test it. It is the correct way around. So if I'm looking at the LED in front of me, the one on my left is ground and the one on my right is voltage. So my resistor must go between that one and that is, let's see, digital pin 13, which is 19. So I put it in place and then I count 15, 16, 17, 18, 19, 20. Okay, so my gadget is one too long. All I do is bend my wire straight again, re-grip it, re-bend it, and put it into place again. So much for pre-bending it. So 15, 16, 17, 18, 19, still the wrong hole, don't know how that happened. 15, 16, 17, 18, 19, it must go into that hole. And there we go, that hole. So in place, just get my magnifying glass. 15, 16, 17, 18, 19, that's perfect. Now I can bend the one side over to hold it in place. Put it in and solder. Just get my tip good clean. I've been forgetting to do that. Put a bit of solder on. And there we go, all nicely soldered. Bend my other pin up straight. And add a bit of solder. And there we go. Once again, clip off the excess, which we don't need, the excess wiring, to neaten up our board. Just quickly throw that away, that's what's moved. Okay, now the next part we need to do is complete our circuit for the LED by connecting it up to ground. So on this chip, it's got two grounds. So I go back to my sketch. of the processor, and I see it says pin 8 and pin 22 is ground, so I can use either one of the two for my ground. So in this one's case, I'll take my green magnet wire. This is pretty good stuff. I recommend it to anybody that wants to use a decent wire. The nice thing about this is it's pretty thin. It's got a protective coating on, and it works pretty well. It can go into pretty small places. You don't have to worry about any problems. I cut it a little bit longer than what I need. Wind my wire back up. Just a little tip with this type of wire: always make a bit of a loop. Wind it the opposite way around. Got my wire there, I loop it back on itself through the little loop I made, and there we go. Now my wire won't come loose on me. Then I can put that aside because I don't need voltage wire now. I just need one piece of green. Now the nice thing about this wire is you put a bit of heat on it, and voila, it's done. So now I've got to go to 1, 2, 3, 4, 5, 6, 7. What am I doing? 15, 16, 17, 18, 19, 20, 21, 22 is over there. 15, 16, 17, 18, 19, 20, 21, 22. Okay, I've got it in 22. I grab it with my helping hand so I can work with it easier. Put my magnifying glass in the way so I can see better. And keep it in place. Go. Now I've just got the wire bent there, and I'll just bent it over that way so I can get a better grip on it. Clean soldering iron dummy, and apply solder. Okay. The excess wire, bend that up, catch it and clip it off. Release, and there we go. That wire is now done. Now, okay, so I'll estimate approximately there is where I need my wire to be soldered, and apply some solder. And there we go. Now these little pieces, even though it's small and it looks like rubbish, is still quite useful if you need just a small wire. So what I do is I take it and I put it away and hope it doesn't disappear. So next I take my wire, I bend it into the position I need it. When it cooperates, it's nice. that. Check it. There we go. Now I've got that piece of wire in place. Okay. And get some light on it. There we go. I've now got the LED in place and grounded. The next part, you'll need a I can't think of this thing's name right now, but its model number is L7805CV. I think this is a transistor. Talking under correction, I can't think of its name now. I think this is a transistor, I'm not sure. But this leg over here, pin 1, is voltage in. Pin 2 is ground. Pin 3 is voltage out. So this will take your 9 volts in and give you 5 volts out. That plus 2 10 microfarad 25 volt capacitors is what I'm going to use to make my power supply. So now I'm just trying to figure out the best place for this on my board, because I want to put it in a position where I can bend it over to give it the least amount of space wastage. And I think this right here will do. So clamp it in place like that. And just get this back in there. Okay, this one I'm gonna try something. I don't know if it'll work. No, it won't work. Okay. Bend that leg over slightly. That works. And apply solder on the first leg. Heat the solder up, push it into position. Okay, I'm happy with that. Solder the second leg. Ouch! Remember, metal gets hot. Okay, I just want to solder the last leg. And there we go. Trim the unwanted legs off. I'll throw that away. Now, next, I've just got to put the two 10K resistors, capacitors in place, and then I'll come show you exactly where they're supposed to be. I'll be back in a second. Okay guys, I've got the capacitors in. Now your positive is on pin 1 and pin 3, your negative is on pin 2. So I've got them in place. Now I'll just quickly solder them. Okay, so there we've go. Now my input voltage is going to come from the power supply to pin 1. From pin 3 it's going to go to voltage on either this side or the opposite side, and ground to either this side or the opposite side. It doesn't really matter which side you put the voltage on, they're basically the same thing. So I'm going to quickly wire those last two pieces up, and then I'll get back with you with showing that this little Arduino is working. All it will show you for the moment is just the blinking of this one light, but that will be for it for now until I've connected the other stuff up, and then I can show you everything working. Be back now. Okay guys, I've now got my power cable connected. I've removed my chip, and this is the 80 mega 328 chip. You also get a 168 chip. Apparently they're pretty similar, the one's just got more cache memory. Now on the top of the chip, right, let me see if right over here is an indentation. On the other side it doesn't have it, and a little circle right here with two circles over there. But this half circle here and this circle over here, this indicates that this pin here is pin 1. Now on my socket I've inserted onto my board, I've got a notch over here which indicates pin 1 is there. So carefully I've got to put my pin in there, and then I've got it. Sometimes when you get the chips, the pins have to still be bent into shape. These ones have already been bent because this has been programmed, and then it's just a matter of pushing it into the socket and seating it in place. Now the advantage of this is I decided, okay, I don't like the way the blink lights, say the nav is, say for argument's sake I think it's too fast. I just pull my chip off, put it back into my Arduino, connect it to the computer and upload the new sketch so I can reuse it. Now all I have to do is just quickly connect it to the power supply, and then we can check. So I'll be back in a second. Okay guys, I've just got my wires jerry-rigged here to the power supply, or I could say I've got it MacGyvered to the power supply just so I can give my board some power. So let's switch it on and see what happens. And there we go. Pin 13's blink is working. Now if I had the rest of the stuff connected to it, I'll be able to fire photons, torpedoes and everything, but all at the moment is I've got the nav light. The rest of it's still got to be connected up. So I will figure out how I'm going to do that. Then I'll connect everything up temporarily and show you that this board is now and effectively a bare bones Arduino. So when I come back, I'll have the other all the lights and stuff connected with the buttons and stuff, and we can take it from there. What I am planning to do is to print out a little piece of paper, hopefully showing me, if this will work, showing me which row of pins is which, so it makes it easier for me just to connect up my nav and all that stuff to it, so I can get it working. But for now, this is all I'm going to do. I'll get back to the rest of the video a little bit later on, and then you'll see. So I'll be back now. For you it'll be a couple of seconds. For me it might be tomorrow night, because here in South Africa it's getting pretty late. It's now 10:32 in the evening, so I don't think I'm going to be doing any more tonight, but I will do a little bit more video with everything else, and you can see it all working. So I'll be back now. Okay guys, here's the model sellotaped basically together with the Enterpris 3 lighting circuit going. Let me just quickly switch it on. There's my 9-volt power supply, and there the deflector dish ramps up. The lights, the strobe, 2 strobe lights on the nacelles, and then nav and strobe light on the top of the saucer section. Now I went and I watched the motion picture, and when you see the shuttle with spark coming in through this section here to dock over here with the bridge, you see these 2 lights actually do strobe. These over here do not. They're permanent on, that's why they're not connected. So there we go, those are 2 strobes with the one at the bottom, and then of course you've got your navigational lights going. You press your deflector dish button, and there she changes to warp mode. I've just got a little LED over here to show the phases, and then of course the all important photon torpedoes. So there we go guys, an Arduino Starship lighting sketch which Trevor designed, propped up on my Enterpris refit. Now with the phases, what I want to do is drill 2 smaller holes through the bottom one, and then make it look like it's firing. Still got to do that, but as you can see it all looks pretty good. So that's all of this so far. Of course you can go and change the flash ratios and all that in the programming. I've got the circuit I've made, I've got in the saucer at the moment, but I think the best place would be in the base, because that way you can go and pull the chip out and reprogram it with different flash ratios if you want. If it's in the saucer, it's more permanent and you can't change it. So that's what this circuit looks like at the moment. Excuse me. I think it looks pretty good. And when we get to continuing the model, I'll show you on some videos how it looks as we build it. So that's what everything looks like. Okay guys, I'll be back now. Okay guys, thanks for watching this video. Hope some of you who's building the Enterpris refit will be able to use this circuit. Trevor will be adding maybe some more stuff to the circuit, I'm not sure. But watch these videos on how to program Arduinos and stuff, it's pretty interesting. As you can see, the Enterpris running in the background, all the labs and everything. Looks pretty sweet. So I hope you guys will enjoy the circuit, and by just modifying certain parts of the circuit you can use it for different models. So hopefully you guys will be able to use this for your different Star Trek and other types of projects which you're doing. Watch Trevor's videos, they're pretty interesting and teach you quite a bit on how to use and program Arduinos, and you can do quite a bit of your model lighting with an Arduino, which is quite nice because you can get to do much more things than what some of the other circuits can do. And Arduino's making a what I call a Arduino is not actually that difficult. There's not that much to it. So as you saw in this video, you can use it for quite a bit of stuff. All you have to do is just get the program right the way you want it, and off you go. Thanks for watching. Subscribe, comment, it will be appreciated. Thanks. Cheers.